Hi, welcome all. In this video, we will be dealing with the Python program for solving a first order differential equation, ordinary differential equation using Euler's method. Fine. Okay, let us discuss the algorithm. We have already discussed that while we explained that numerical problem. Now, the idea is this. Let's define the problem first. We will be given y dash as some f of xy, and we'll also be given one information at x is equal to x0, y is equal to some y0, and we are supposed to calculate at some x what is y. So we represent that using some table. So we'll have some x and y values, some x0, you know what y0 is, and at some point, say some ux, let me call it as unknown x, you don't know what y is, so you have to calculate what is this y. So you know that you cannot make a giant leap. Instead, you must start from x0, y0, you must march to it x1, y1, such that the distance from x0 to x1h must be very small. So you can calculate, either you can input h or you can calculate h. Suppose you are making some n steps to march towards ux. You are taking n steps to march towards ux. Then to travel the distance ux minus x0, you must travel ux minus x0, you are making n steps, so that your step size will be like this. Okay, now what you have to do is, your step is this. You must first initialize these values. You must know what is your initial value of x. You must know what is your initial value of y. So you may initialize, or you may read from the keyboard. You must input how many what is your unknown x, then how many steps are required to reach the point. Then you must calculate the step as ux minus x, then divided by n. Okay, so this way you can calculate x. Now what are the iterating steps? You must iterate something like this. You must calculate the new y using the formula previous value of y plus h into f of xy. So you must know what f of xy is. So in the beginning, usually we define f of xy to return the given function. Then what's the next step? You must calculate the new value of x as x plus h. And if you wish, you can print the results, print both x and y to see the results. Now the problem is this, how many times we have to repeat the steps? There are two possibilities. One is you must have n steps, so that you can iterate that n times. So, or you can stop this process, and as long as you haven't reached ux. If you are at ux, you can stop, or if you are at some x1 or x2 which is not ux, you need to proceed further. So if you are using a while loop, then you can use this condition: while your unknown x, while your x is less than ux, you must proceed. So when your x is less than ux, that means you haven't reached ux. You can use this condition if you are using while loop. Or if you are using for loop instead, in this case you can write for some I in range n. That will do, because your iteration is n times. So it's optional, so it's up to you. So let me try with while. You may try the code, you may copy the code, and you may try with the for loop. Now let's consider the previous example in which our f of xy is 2x. You must begin with x equal to 0 where y is equal to 3. Hope you remember. Otherwise I asked you to refer the previous video which explains Euler's method. In the numerical example we have chosen these values, and your unknown x was some 0.3, and your n, we solved that with the step size 0.1, and for that there are 3 steps. So you'll choose n. Okay, so this will give you the required steps. Now we shall see the code and we will run the code. Okay, let's translate our algorithm into Python code. So the first step is to define the given function. So we define f of xy as 2x. Then we initialize the x equal to 0, y is equal to 3, ux equal to 0.3. Number of steps are some 3, because we made only 3 steps in the numerical example. Then we calculated h. Then we have printed the h value just to see this. Then while x is less than ux, I just translated that into Python. What does this mean? My x is going to increase continuously in every step. So at some point, if your x is still less than ux, you have to proceed further. And if your x is equal to ux, you need not proceed further. So that's the idea. So y is equal to y plus, these are the only iterating steps. Y is equal to y plus h star f of xy, and x is equal to x plus h. Now we must print xy. Okay, so that's it. Now let us see the result. So I run the code and my h is 0.099 like that. So if you just print h, you can see that it is 0.00999. Now if you round that, it will be just 0.1. Then you can see the final result as at 0.3, it is 3.06. All right. So this is in agreement with the numerical example we have discussed. So please remember our final result is 3.06, and hope you remember the actual result must be 3.09. Okay. So those who have not watched the previous video fully, you please go back and watch the video. There we have discussed the same problem numerically, and we just created the problem, and we know that the exact result is 3.09. So please go back and watch the video. All right. Now let me increase the number of steps to 30 so that the step size will be some 0.01. So this time my step is really small, and as I already remarked, Euler's method gives acceptable result if and only if your h is really small. All right. Okay. You can actually see the step size. It's h is equal to 0.01. Now it has made some 30 steps. You can see in every step what my y value is, and finally at 3.3 the result is 3.0869, which when rounded the exact result must be 3.09. Okay, this is in while agreement, so it works fine. So you may try with the different step sizes and see how the result improves. Okay. Okay, so I request you to try different first order differential equations with the different initial conditions by yourself and see how Euler's method performs. In fact, Euler's method is not a very good numerical method for solving ordinary differential equations. However, that gives better result in many cases, especially if the step size is really small. Thank you.